Projectile, Part 1. A ball is thrown, and it describes a curve like that. So this is the ground level, the ground. And let's label the starting point, call it A, and let me label this point B. And there is a highest point, let me mark this as point C. What I want to find is how much time it takes to reach the highest point, how much time it takes to fall back to the ground. So I want this t is what? I want to find this t is what? And the time here, I call it t equals 0. Okay, this t equals 0. You start from time 0 and find this time, this time. Let's give the time a subscript, the time at point B. And this time is the time at point C. Okay. The formula we use are the kinematics equation. So V final is equal to V initial plus acceleration multiply time. And another equation is the displacement vertical is equal to V initial, I just use I, V initial times T, plus 1/2 acceleration T squared. Remember, these two equations refer to the vertical component. So the V final is the vertical, and V initial is vertical. Just remember the vertical part. This is vertical part. All right, we are going to use these two equations. First, let's find the time at point B. So look, between A and B, what is the vertical displacement? It's 0, right? Because A and B are at the same level. So I use the displacement formula. So the vertical displacement between A and B is 0. And I need initial velocity. Initial velocity of the vertical component. Let's say the vertical component, just for simplicity, the vertical component is just Vy. Just for simplicity. At point A, the vertical velocity is Vy. So I can write Vy t. So I want this time, all right? So I write Tb is plus 1/2 A. Now, for the vertical part, my acceleration is 9.8 downward. So I write minus 1/2 9.8 times squared. This time is Tb squared. So let me repeat. The acceleration is 9.8, but the acceleration is downward. Therefore, I need a negative sign here. And the whole thing is equal to 0 because the displacement between A and B, the vertical displacement is 0. This tells me that I can factor out Tb. So this is equal to Tb bracket Vy minus 1/2 9.8. I factor out a TB, so I have 1 TB left. So I have the answer for time at B is TB is 0, and also Vy minus 1/2 9.8 TB is equal to 0. So I can solve for TB. What is TB? Then you can solve this mentally, right? So you just put this into the right-hand side, and you can have TB. So the TB is what? TB is 2 times Vy divided by 9.8. So this is my time at the location B. So next, I want to find the time at the highest point. So remember, at the highest point, there is only horizontal velocity. The vertical velocity should be 0. This is our condition at the maximum height. Because if the vertical component velocity is not 0, it will either go up or go down. But now, you see at maximum point, it only goes horizontally. Yeah? Therefore, the vertical component has to be 0. So what do? I use this equation. The final vertical component of velocity has to be 0 at point C. So I write at point C, at C, the final velocity, this is my final velocity, this is my initial velocity. At point C, my final velocity, vertical, should be 0, and it should equal to initial velocity, which I label Vy, plus acceleration t. But acceleration is 9.8 downward. So I write minus 9.8 t. Now this t is at point C. So I write Tc. So this whole thing is equal to 0. So it is very easy to find Tc. What is Tc? Tc is Vy divided by 9.8. Okay, this is my Tc. Let's compare Tc with Tb. Look, this time is double this time. It's so clear. Or we can say the time to reach C is half the time to reach B. So Tc is half the time to reach B. So far, so good. I think you follow me, right? Okay. There, I can specify another point, which is half the maximum height. So I can see this. I want the time here. And this is the highest, the maximum height, the highest point, h maximum. And I want a special point, which is 1/2 the maximum height. From the diagram, you will see that there are 2 points at half the maximum height. This is also 1/2 h maximum. I want to find how much time it takes to reach this point and how much time it takes to reach this point. What's the time here? What's the time here? Okay, let's again give these 2 points a label. So I have A, B, C. Why not give it point D and point E? I want to find TD is what, and T at point E is what. So the next is to find T at D is what, and T at E is what. So how do we do that? We need to find what the maximum height is. Because at D, my condition is that this height is half of this height. So I need this height, and then I can find half of this height. Then once I have this height, I can find the time. So what I need to find is the highest maximum height. So how do I do that? How do I do that? I use the distance equation. I use the vertical displacement equation. All right. At the highest point, the maximum height, use this equation. The maximum height is initial velocity times the height to reach the maximum, plus 1/2 acceleration times the time squared. This time is the maximum height time. So I use this. Okay. Initial vertical velocity is Vy. For maximum height, I need the time at maximum height, but I already have it. The time at maximum height is my TC, and my TC is Vy over 9.8. So this is Vy over 9.8. Plus 1/2 acceleration. Remember, acceleration is 9.8 and it's downward, so I have minus 1/2 9.8. And the time squared. The time is the time to reach the maximum height, which is my TC. And TC is this. So I need to square this. All right. Let's simplify this. So this is equal to Vy times Vy is Vy squared. And divide by 9.8 minus. Look. This bracket squared means Vy is squared and 9.8 is also squared. But I have 9.8 here. Therefore, I can simplify 9.8. This is what I get. So Vy squared. I have a 2 in the denominator. And I have 9.8 here. Okay. So, what is my maximum height? Do this now. So, if you do common denominator and simplify this, what you get is Vy squared, and 2 here, and 9.8. So that's my maximum height. Do you follow? Okay, carry on. Now once I have the maximum height, I need to find the time at half maximum height. So next is to half maximum height. This is my maximum height. Half of this, it's not difficult. Half of this is, the 2 becomes 4, see? Okay, this is my half maximum height. Now, I'm ready to find the time to reach half maximum height. So I use the displacement equation here. I know the height, vertical height. Okay, what is the vertical height? Here. So I write this way. Vy squared 4, 9.8. This is distance. Then the initial velocity. The initial velocity is Vy. The initial velocity is Vy. So initial velocity is Vy. And multiply the time at my half maximum height, which I don't know. So I write TD. Oh, okay, I want to find TD. So TD minus 1/2 9.8. And my time at point D squared. I want to find TD, right? Look, I have TD here, I have TD squared. So as far as TD, the unknown, is concerned, it's a quadratic equation. So I need to rewrite it. I need to arrange it in the standard form of quadratic equation. So I do this, 1/2 9.8 TD squared. I move this to the left-hand side, and I move this to the left-hand side, minus Vy TD plus this. And the whole thing equals 0. I don't want the denominator, so I multiply multiply 4 times 9.8. So what do I do? What do I have? So I have this times that, it becomes 2, 9.8 squared, TD squared, minus 4 times 9.8 Vy and TD, and a plus, I only have Vy squared, right? All right. This is a quadratic equation. I can solve for TD and just use the quadratic formula. All right. Let me write here. So what is TD? Now TD use the formula. TD is the denominator is 2a, 2 times a, 2 times this, 2 times 2, 9.8 squares. So it is 4, 9.8 squared. So here I need minus b. What is my b? B is this. Minus b, minus cancel this minus. So b is 4, 9.8 Vy. 4, 9.8 Vy. And plus minus square root b squared minus 4ac. Now b is this. So I need to square this, which gives me 16. 9.8 squared and Vy squared minus 4ac. 4, what is a? A is 2 times 9.8 squared. So that's my a. 4 times 2 times 9.8 squared. What is my c? C is Vy squared. So I have a Vy squared. Oh, I have no space there. So I have here Vy squared. Okay. So let me simplify this part. The part inside the square root sign. So I have TD. All right. I don't have much space here, so just squeeze it. All right. Look, what is 2 times 4? 8. So this is 8, 9.8 squared, and Vy squared. Look here. I have 9.8 squared and Vy squared. So this part and this part, you can subtract and reduce it, make it simpler. So 16 minus 8 is 8. So I have 8, 9.8 squared, and Vy squared. Do you follow? So the bottom is 4, 9.8 squared. Carry on. 4, 9.8 Vy plus minus. Look, I have 9.8 squared. Take square root, then I have 9.8. Vy is squared. Take square root, I have Vy. And here, square root 8. Square root 8 is 2 times square root 2. It's 2 square root 2, correct? So I have 2 square root 2. This part comes out, it's 9.8. This part comes out, it's just Vy. Divided by 4, 9.8 squared. Continue simplification. I have 2, 4, 4. So I can divide everything by 2. So it becomes 2 here. Then this 2 is gone. And this 4 becomes 2. Also, I have 9.8, 9.8, 9.8 squared. So I can cancel 9.8, 9.8, and one of the 9.8 cancels. So I have this. This 4 becomes 2. And this square becomes just 9.8. And this 9.8 is gone. This 9.8 is gone. And I have Vy left. See, this is Vy. So Vy can be factored out. Let me write Vy here, factor out. So what do I left here? This is cancelled. Vy is out. 4 becomes 2. So I have plus minus. 2 is cancelled. I have square root 2 left. 9.8 is cancelled, and Vy is outside. So this is what I have. Let's see this. There is an interesting thing here. Vy divided by 9.8. Look, Vy divided by 9.8 is my time at point C. So I rewrite it. 2 plus minus square root 2, 2. I move this underneath the Vy. Because I see this part is just time at point C. So I can write time at D is 2 plus minus 2 divided by 2 times time at C. So that's my result. Why do I have plus minus? I have 2 results for TD. Actually, this is not just TD. This, because I got this by using half maximum. Here. Half maximum height. So this is half maximum height. So this TD actually means the time at half maximum height. And look at this diagram. Half maximum height, I have D and E. I have 2 points. What this means, plus minus, is one answer for D, another answer for time at E. So I have 2 times time D plus minus. Which choice corresponds to time D? Of course, it takes less time to reach D, and it takes more time to reach E. So time D is the less time, which is minus sign. And time at E, it takes more time to reach point E, so it is 2 plus square root 2. Do you follow my argument? Now, you are ready to use calculator to find the numerical value of this and find the numerical value of this. And I did it, so this is my answer. This part is approximately 0.3. And this part is approximately 1.7. Okay, this is my result. So what does this mean? The point to reach D is 30% of the point of the time reach C. All right, go back to this. This time and this time, the relation, this time is 30% of this time. So one of my students said, this is half the maximum height. This is maximum height. So one of my students said, he just assumed the time to reach here is half the time to reach here. That is not right. You see, it's so clear. The time to reach this point is 30% of the time to reach this point. The time to reach this point is 1.7 times the time to reach this point. So these are the two important results here. Finally, for part 1, I want to conclude part 1. Let's have a special number for the vertical velocity at the beginning. Let's say this Vy is 9.8. Why do I want to choose that special point, a special value? Because, look, the time to reach B is 2, here. The time to reach B is 2 Vy over 9.8. If Vy is chosen to have a value of 9.8, then TB is 2. So it takes 2 seconds. It takes 2 seconds to reach B. And since this time is half the time here, so the time reached here is 1 second. So 2 seconds here, 1 second here, and 0.3 second here, and 1.7 second here. So if Vy is 9.8, then TB is 2 seconds, TC is 1 second, TD is 0.3 second, and TE is 1.7 second. That's all I want to say about part 1. And we will have part 2 in the next video. Thank you.